À 0 moins 1 minute.
T-minus 30 seconds and counting. Engine start. And liftoff.
Décollage.
From a tropical rainforest to the edge of time itself.
We have always looked up at the night sky, wondering how those stars came to be. How did the cosmos take shape from the darkness of the Big Bang? Now, we finally have answers. But they are not what we expected. The James Webb Space Telescope has just shattered its own record, detecting the most faraway galaxy ever found. We are witnessing a group of stars that were only 290 million years old when the Big Bang occurred. To put that into perspective, if the universe were a 100-year-old person, this galaxy formed when it was just 2 years old. But here's the real shocker. This galaxy isn't just distant, it's huge, 1,600 light-years across, filled with young, bright stars, and already enriched with heavy elements like oxygen. This shouldn't be possible. Our current models say that galaxies take billions of years to grow to this size. Yet, here it is, a cosmic paradox that challenges everything we thought we knew. How did such a massive, bright galaxy form in so short a cosmic time? What secrets does it hold about the birth of the first stars? And could this mean that even older galaxies, ones beyond our wildest predictions, are waiting to be found? Strap in, because today we are traveling beyond the dark ages, to the edge of the known universe, where the James Webb Space Telescope has unveiled a strange, impossible phenomenon. The James Webb Space Telescope was launched in December 2021. Its singular mission, to look deeper into the past of the universe than any telescope before it. A 6.5-meter wide primary mirror and ultra-sensitive infrared instruments would aim to capture light from the earliest galaxies to unveil cosmic history's secrets. And just recently, it has done exactly that. It has shattered its own record by spotting the farthest galaxy ever, JWST 140. This galaxy was found in the course of the JWST Advanced Deep Extragalactic Survey, a project intent on finding out the first structures in the cosmos. What makes this galaxy so special is not just its distance, but rather what that distance says to us. According to astronomers, the galaxy that we know only 290 million years after the Big Bang. And that makes the universe 13.8 billion years old. This means we are seeing the galaxy as it was when the cosmos was only 2% of its current age. But here's the truly astonishing part. It isn't just some tiny, faint object struggling to form in the early universe. It is huge, more than 1,600 light-years wide, and very bright. Usually, such brightness in young galaxies is linked to big black holes sucking up nearby gas. But here, the light seems to shine from many new burning stars. Astronomers didn't think they would find a galaxy this big, this bright, or this rich in chemicals so early in the history of the universe. According to current ideas, it shouldn't have had enough time to grow. Yet, there it is, challenging our understanding of how the first galaxies took shape. This discovery is a cosmic puzzle, one that forces us to rethink the speed at which galaxies can grow and whether our fundamental models of the early universe need to be rewritten. And the surprises don't stop there. JWST 140 holds another revelation, one that could reshape our theories on star formation itself. The James Webb Space Telescope is a time machine, capable of viewing the past as it was billions of years ago through the faintest whisper light from the universe's earliest days. But how does it do this? The answer lies in something called the redshift. JWST has a redshift of 14, meaning its light has been stretched so much that what was once visible light is now deep in the infrared. That is why Webb, designed to detect infrared light, was able to spot it, while previous telescopes like Hubble simply couldn't. The Hubble Space Telescope changed our understanding of the universe, but it had a flaw. It could only see invisible and ultraviolet light. According to that theory, The early galaxies whose light had shifted into the infrared were actually invisible to Hubble. So there were quite a few galaxies that went unnoticed. Webb, however, was engineered for this very challenge. Its huge 6.5-meter mirror and tools sensitive to infrared can spot light that has been on its journey for more than 13 billion years. That's why it was able to see a galaxy from an era that was once beyond our reach. In a thrilling possibility, if Webb could find a galaxy at 290 million years after the Big Bang, maybe there are even older ones out there waiting to be found. Astronomers believe the first galaxies may have formed 200 million years after the Big Bang. In that sense, the detection prowess of Webb implies that we are on the brink of being able to look at the real cosmic dawn, the moment the first light of the very first stars in the universe broke through the darkness of the early cosmos. If JWST is just the beginning, then the next great discovery may be even closer than we think. Discovering the farthest galaxy is more than just another record-breaking look. It challenges what we know about how galaxies came to be in the early universe. According to current models, such a big and bright galaxy shouldn't have been there less than 290 million years after the Big Bang. Yet it is there, shining across the sky and forcing astronomers to rethink how fast galaxies could form. Long ago, scientists thought that early galaxies were small, fuzzy, and not very symmetrical, just accreting slowly over hundreds of millions of years. Its brightness suggests an overall mass that is hundreds of millions of times greater than that of our Sun, so it must have formed and accumulated mass very rapidly. The oxygen abundance in the galaxy is one of the most surprising results. Heavy elements such as oxygen did not exist in the early universe. They were produced within stars, and premature supernova explosions expelled them into interstellar space at the death of those stars. The observation of such large quantities of oxygen in the Lyman Break galaxy indicates that many generations of massive star life cycles had occurred long before we saw this galaxy. This means that star-making must have been happening at a very fast pace. This discovery poses a basic question. How did such galaxies like JWST come into existence so rapidly? Did the conditions of the early universe allow for more rapid star formation? Were galaxies assembling in ways we don't yet understand? The implications go beyond just one galaxy. If this one exists, there could be many more like it. And if Webb can see galaxies from 290 million years after the Big Bang, it may soon extend the boundary even farther back, to the first 200 million years, when the universe was just lighting up. Every new revelation from Webb adds an extra piece to the puzzle of cosmic evolution. Yet this farthest discovered galaxy is not just a piece. It's a challenge, a mystery, and an indication that the very early chapters of the universe might be much more complex than we ever had in mind. The discovery of early galaxies is just the beginning. But with Webb detecting one so massive and bright only 290 million years after the Big Bang, what more is left to discover? This implies that the formation of galaxies might have taken place much earlier than what has been estimated till now. Therefore, we might just be about to push the limits of observable cosmic history even further. Astronomers are now refining their search to galaxies that could be as early as 200 million years after the Big Bang. If Webb finds them, it will completely reshape our understanding of how quickly the first structures in the universe came about. The next step is conducting detailed spectroscopic studies of JWST and similar galaxies to understand their chemical composition, star formation rates, and overall evolution. Webb is also hunting for the very first stars, those population 3 stars. Never seen before, these stars are made up entirely of hydrogen and helium. It would reveal the manner in which the primordial substances, greater than helium, were created, their root contributing to worlds, existence, and all we observe today. Other observatories set to be launched soon, such as the Great Large Telescope and the Nancy Grace Roman Space Telescope, will enhance what we gather from Webb, assisting us in shaping a more complete picture of the youthful universe. Each discovery brings us closer to understanding. How did it all begin? This newly discovered farthest galaxy has already challenged some of our fundamental assumptions about the early universe. But if Webb made any discoveries that taught us something, it's how full of surprises the cosmos is, and that the best is yet to come. The latest finding of the faraway galaxy is a mystery. As per our present knowledge of cosmology, galaxies mustn't have had enough time to form on such a large scale, just 290 million years after the Big Bang. This has made some researchers think about other ideas, challenging the limits of what we believe about the start of the universe. One possibility is that our timeline of the early universe needs to be changed. Some scientists say that the universe might be older than the commonly agreed upon number of 13.8 billion years. If the universe had a longer time to grow before the first galaxies showed up, it could help explain how such a big thing like JWST 14.0 could be there so early. But this idea goes against many strong models of how we see the universe, which are shaped by facts from the radiation of the cosmic background and the speed at which the universe is getting bigger. Another theory is that something amazing took place after the Big Bang, which speeded up the making of galaxies. Perhaps certain physical processes in the early universe, such as unusually rapid star formation, allowed galaxies to take shape much faster than models predict. If it's true, it would mean that our theories of how matter condensed into stars and galaxies need serious revision. A more radical theory suggests that our understanding of dark matter and dark energy, the mysterious forces that make up most of the universe's mass energy, could be incomplete. Some researchers speculate that unknown interactions involving dark matter may have caused galaxies to form much earlier than expected. If so, JWST could be our first real clue that these invisible forces played a more significant role in shaping the early universe than we previously thought. Then there's the conformal cyclic cosmology hypothesis from Sir Roger Penrose, a Nobel laureate. He proposed that the universe didn't begin with the Big Bang, but has gone through infinite cycles of expansion and collapse. According to this idea, structures from a previous universe, possibly even black holes, could have survived into our current cosmic era, influencing the formation of early galaxies. Still, highly speculative. It raises the possibility that the universe is far more complex than we imagined. At this point, no single theory has sufficient evidence to rewrite our cosmic history. But one thing is clear. Webb's discoveries are forcing us to ask questions we never thought we would have to ask. JWST 14.0 might just be the first of many clues leading to a deeper, more profound understanding of the universe.